Everyone. In this project, we're going to create an app called Facemesh Filter Camera. I'm sure you have played with Instagram or Snapchat facial filters, and you are aware how popular these are. But you may not know how these filters work. How do they follow your face, and wherever you turn, they also follow your face. So we're going to learn how to make these facial filters. It's going to require a little bit of math, a little bit of computing, but it's not too hard. Before we start, though, I would like to quickly demo what the facial filters look like. So I'm going to quickly create a QR code, and I'm going to quickly scan the QR code. And we have a visor tool here, and we're going to quickly demo this on this visor tool. It might take a few seconds for the images to install, and also it might take a few minutes for the picture to go live. But now you can see that there is me in the center of the image, and then there's a face filter pasted appropriately. If I go away from the camera or get close to the camera, if I go to the right or go to the left, you can see that for the most part, the face filter is in real time following me and the position of my face. Now, once you're done exploring this facial filter, you can take a photograph of yourself by pressing the Take Photo button.
Photo captured.
And you could share the most recent image that you have taken with your friends using your favorite app. So I'm going to use Gmail. And here you can see that the image has been captured, and you could forward it to an email address of your friend if you desire. So we're going to learn how such a thing is possible to do. So if you go to Facemesh Filter Camera webpage, you're going to see that there's a resource URL there. When you click on that, it will bring you to this starter project. In the starter project, on the left side, you can see that there's a tutorial that's going to guide you step by step in this process. It starts with a challenge description, and then it has some instructions how to set up your computer if you have never done this before for App Inventor. But then there are 17 pages of tutorial which you can navigate step by step, go through and figure out how this is done. Now, you can also toggle the tutorial. If you don't want the tutorial to show and you want to have the entire screen taken by the App Inventor interface, you could do that, or you could toggle it back as you desire. Okay. Now let's see what we have. Let's start with the media. Here we have a bunch of PNG files. It says cat left ear, cat right ear, cat whiskers. So if you like to have the face filter being in the shape of a cat character, these are all the body parts that you're going to need. And similarly, you could also select a lion character, and the left ear, right ear, and whiskers for the lion is also available here. Now we have we have a canvas, and we have a bunch of image components. And what these are is we're going to assign them these PNG files in a minute, depending on the character that you choose. Here we have a Take Photo button. It does what you expect it to do. And we have a Share Most Recent Image button, which will share the most recent image that you have taken. Okay, now let's start by assigning left ear, right ear, whisker pictures. So I'm going to click on the left ear here, and you're going to notice that there's already some parameters given here, like height, width, etc. So what I'm going to do is I'm going to assign for the picture for left ear, I'm going to assign cat left ear. You are totally welcome to select the lion left ear if you desire. And then I'm going to do the same thing for right ear. I'm going to select picture, cat right ear, okay that. And whiskers, I'm going to select cat whiskers, I'm going to okay that. Okay, so the image of the cat already starts appearing here. Now, there's a couple of other components here that we should talk about. The visible components we talked about, but there are some non-visible components. The sharing component here is going to be used at the very end. When you press the share button, it's going to share your image that was captured via an app that you choose with your friends. Face extension is the Facemesh extension. This is the extension that allows App Inventor to track your facial parts. And then we have a text-to-speech component. When you press the Take Photo button, this text-to-speech is going to make sure that there is some audio feedback that a photograph has already been taken. Okay, now let's go to the code and let's see what's happening here. So there are quite a few of the code that's already created for you that you don't have to worry about. For example, how to take a photo button, when the photo button is clicked, what to do. This is already created for you. In a nutshell, it creates a file with a particular name and with a JPEG extension name. And it basically has the text-to-speech component say a photo has been captured. So you don't have to do anything with this particular event handler. This block has been written for you. The same for share photo button. The code is given here. You basically call sharing.share file, and you give it the most recent photo that you have taken, and the rest is done by the app itself. It will connect you with the correct apps to send your photo to your friends. Now, the most important procedure that we're going to have to write in this project is the place image procedure. And if you look at the inputs for the procedure, there is the first one is called IMG for image, and the second one is called face point. So place image requires an image to be given to it and the face point to which to paste the image. And we're going to learn in a few minutes that there are some computations that need to be done because of some peculiarities of how images are placeable in App Inventor. But moving on with the code so we can see what else is here. When face extension face updated, we basically have the canvas. We capture the background image coming from the face extension and make it the background image for the canvas. This is basically going to be a live feed of your face, and that's going to become the background image, but it's going to be constantly changing. There are two procedures that are called here, moving and resizing, and we will create the moving procedure ourselves. We're going to talk about how to do that, but resizing has been created for you, and I will explain to you as the time comes how to do that. Now, it's quite important to understand how the Facemesh works, how the face extension works. So I'm going to quickly show you this image here. So this is a map of the face of the user. And what you see that it basically is like a mesh, and different points on this mesh corresponds to different landmarks on a face. Here is the left forehead, right forehead, the left cheek, the right cheek, left eye top, left eye inner corner, left eye bottom, and similarly for the right eye, chin, etc. It actually turns out that Facemesh is able to track 486 different points on a face. So all these unnamed points are actually also being tracked. But App Inventor will make these important landmarks available to you in the form of blocks so that you could use them, assign them, etc. It is quite important to understand how the App Inventor coordinate system works and how it might relate to the Facemesh. Now, the origin of the App Inventor coordinate system is at the top left. It is not at the bottom left, as you might think so. Basically, the x-axis goes from the origin to the right, so it increases as you go to the right. And the y-axis, the values go higher and higher. They increase as you go down. So this is a little bit counterintuitive, but if you work with any other graphical packages, this is not uncommon. This is actually the standard way of describing a coordinate system in computer science. So you could imagine the Facemesh planted on this coordinate system. So when we want to specify the location of a point, we just refer to it by its x value and y value. Now we arrive, arguably, the most challenging and important part of the project. So let me explain this with an image. Now, what we're trying to do is, so imagine this circular shape to be your face. What we would like to be able to do is paste this image, in this case, image of a cat's ear perhaps, to a particular point on your face. So this x sub f, y sub f is the x and y coordinates of the facial point to which you would like to paste the center of your image. Now, the issue here is in App Inventor, you can only paste images based on the coordinates of its top left corner. So this x sub c, y sub c, representing the x and y coordinates of the top left corner, needs to be computed from the xy coordinates of the facial point. So we need to do a little bit of a math. Hopefully it's not too scary. Let's understand the logic of this. Let's just think about the x values first. So if I'm given the x sub f, the facial point's x value, I basically need to subtract half the width of this image. So this is the entirety of the image. This is half the image. So if I just subtract half the width of the image, I will land at the x coordinate of the top left corner. Similarly, if I'm given the y coordinate of the facial point right here, and I need to find the top left coordinates y value, all I have to do is subtract half the height. So you can see the entire height here. This is half the height. Now, you might say, why are we subtracting half the height? Shouldn't we be adding half the height? I'm just going to quickly remind you that in App Inventor, the origin of the coordinate system is at the top left corner here at 0, 0. And as you go down, the y values increase. So if you are interested in going up, you have to do a subtraction from the y values. Okay? So if you think about it a little bit, it will make sense. It just requires a little bit getting used to, but it is not a terribly complicated math. Now what we're going to do is we're going to write down the procedure place image. So this procedure is going to basically take an image as an input, and the face point as an input. And via doing some math here, we're going to learn how to paste the image appropriately on the face point. So let's do some math. Now, we said a minute ago that that we're going to require the facial coordinates x sub f and y sub f. Now, to do that, we're going to have to remember that face point is a list of two values. The first value is the x coordinate, and the second value is the y coordinate. So what I need to do is I need to go to my list operators, and I'm going to find this block that says, give me the list and index, and I will retrieve the item for you. So the list is the face point, and the index for the x coordinate is the first value, the first index. I'm going to make that 1. And I'm going to need in a second the y value, so I'm going to duplicate this block and change the 1 to a 2. Okay? So this is our x sub f and y sub f. And remember, we're going to subtract from them half the width for x and half the height for y. So let me start by putting half. Half is just 0.5. And I'm going to duplicate twice. So I'm going to put it here, and I'm going to put it there. Now, the last step is we have to figure out how, given an image, how do you access its width and height? Now, to do that, what we have to do is go to the bottom here. You're going to see there is something called any component. Most people have never used this before, or they may not be aware of this capability here. So this is for any component. So if you click the plus sign, it will open as a menu. Now, our image components that we're going to be working with, these are image sprites. So you click on that, and if you scroll towards the bottom, one of the options there should be image height and hopefully towards the bottom, image width. So I need those two parameters. So I'm going to grab the width here. And actually, I can also duplicate that and use the menu to capture the height. So that's another way of, instead of going here, you could also capture like that. So image sprite dot width of components. So I need the component to be able to talk about it. Our image is right here, img. So I'm going to get image. I'm going to plug it in here. And I'm going to quickly duplicate that and plug it in here. Okay? And observe these are undefined because we are outside the procedure. But when I plugged it where it belongs, right here, and then right here, you're going to notice that cross sign disappears, meaning it is now well defined. So what we created is basically a procedure given an image and the face point to which you want to land the image. It basically does a little bit of computation, and it moves that image, which is an image sprite, to the x and y values that you have computed. Okay? So this is, I would argue, the hardest part of this project. It requires some computation. It's not terribly complex a computation, but still there's a lot of things to keep in mind. Right, now that we have written our procedure, which is the place image procedure, we could write down the moving procedure, which basically will place the left ear of the cat, the right ear of the cat, the whiskers of the cat, to relevant facial points. So let's start by writing the first one. So let us get the image, which is the left ear image. So let's grab that. So if you click on that, the left ear, a bunch of buttons, blocks show up. At the very bottom is a block that refers directly at the left ear image sprite. So I'm going to put that as our image. Now, the facial point to which this is going to be pasted, you can grab that from the face extension itself, because the face extension is the one part of App Inventor right now that is keeping track of the facial landmarks. So I click on face extension 1. When I do that, you'll see that there are references to all these facial points. What we would like to have is left forehead. So let's paste the left ear image on the left forehead of the face. Okay? Now we're going to do a similar thing for the right ear. I'm just going to do a copy paste, and I'm going to switch left ear to right ear. And where it says left forehead, I'm going to copy paste again. I'm going to quickly change that to right forehead. Okay? So the ears are now placed. Finally, we would like to place the whiskers. So let me copy paste one more time. And I'm going to find the whisker option here as the image. And let us paste it to the top of the mouth. So let me find mouth top. Okay? So this should be a reasonable placement of these images. Now we're going to test our product in a minute. I just want to make sure that you are able to appreciate what we have done so far. So we created a procedure called place image, which takes an image and a facial point and pastes the image on that face point. We have a procedure which uses the place image procedure several times to place the left ear, right ear, and the whiskers to the appropriate parts of the face. Now, we have a very important event handler here. It says when face extension face updated. So as you move your face, constantly new information is going to come, and this event handler is going to be called. So what's going to happen is the background image is going to be set properly to your image, and then it's going to call the moving procedure which you just finished, which will place the left and right ear and the whiskers. And then it will also do some resizing, and this procedure has been written for you. And resizing is needed because as you get your face closer and farther from the camera, the ears and the whiskers must become larger or smaller. Okay? This procedure has been written for you. It is somewhat random. I mean, these choices may have made other choices. I'm going to quickly go through these with you. We set the whiskers width to be equal to the face width. So the whiskers are basically, we're saying, as large as the face width is. The whiskers height is equal to the distance from the eye to mouth. So that height is going to determine the whiskers height. Is this random? Could you have used double this value, half that value? Absolutely, you could have done. It's just a choice that we have made. Now, left ear's width is equal to cheek to nose distance. So cheek to nose distance, I am wondering if we could have an image that could be helpful here. We're going to basically, let me go to here. Maybe this image might be helpful. Cheek to nose distance. So cheek to nose distance, whatever that distance is, we're setting the width of the ear to that. Again, kind of arbitrary, but it could kind of make sense. You want that distance to be approximately the length, the width of the ear. So the height, we want it to be also equal to the left ear's width because we want the shape to be squarish. And you do the similar thing for the right ear's width and right ear's height. These are completely arbitrary, but they should work. And believe it or not, we're done with the coding here. So we learned how to place an image in App Inventor, and that's really was the major challenge. So why don't we take a few minutes to go to AI Companion, and I'm going to quickly show you my tablet here so you can see the process that is happening. So I'm going to quickly scan this code. I'm going to quickly scan the code, and this will take a few minutes. We have a lot of images to upload, so don't be frustrated if this process takes a while. Okay, and then when the app appears, there is also a little bit of time that is needed for the face extension to start processing things, but in a few seconds it will. And you can see here a face filter on my face. As I get closer to the camera, the filters grow naturally. As I grow distant from the camera, the same thing. As I move to the right or left, they follow me. Now, obviously, we haven't done any complex computation, which basically will be needed if I tilted my face. As I tilt my face, I don't think necessarily the components are growing appropriately. So that's a kind of math that we haven't done. So ours is an elementary type of a face filter where it acknowledges the resizing that is necessary as you get close and far from the camera and as you move to the right and left. It doesn't deal with tilting of the face one way or the other. But that's something you could try to do when you have seen some college level mathematics. All right, everybody. So this is it. This is the program we wanted to develop. Now, there are some discussions that could be made here, and I'm going to quickly show you here some, an article that was published at MIT Technology Review, the magazine. Now, these facial filters are actually quite controversial. It has influenced people in different ways. In some cases negatively because people start getting obsessed about how they look. So there are some articles that could be read here, and that could give you some idea about what could be some of the the negative effects of facial filters in applications such as Instagram and Snapchat. Okay, so this is it for our discussion. I hope you enjoyed. It has been a pleasure. Take care.